from here, I'm going to take the first screen. Gonna start sharing. Uh, Let me know if you are seeing the screen.
Yeah, we can see the screen.
Okay, good. First of all, let me share the link for the presentation because there will be lots of links embedded in here that we are going to open later on. First of all, hello everyone. It's nice to meet all of you. I'm seeing 270 people online. This is by far the largest amount of people that I'm teaching ever. So it's great to meet all of you. Today's session will be about AI agents and how you can use them using open source tools, mainly Hugging Face tools. All right, let's get to it. And yeah, soften a little bit to break the ice. Let's move on. Let me introduce myself. Okay, let me introduce myself. My name is Hafta Hishri, but you can all call me Lane. I'm a Hugging Face fellow, a software engineer at Chonky. I also write technical blog posts in my free time. Lately, I've worked on a blog post about VLMs. The one before it was about KV caching. So if you're interested about them, feel free to click on this link to check them out in real time at your own pace. And let's start. All right. So first of all, let us start by some theoretical stuff. We will be trying to explain what are AI agents, different types of agents, and later on there will be some coding towards the end of the presentation, so bear with it. First things first, what are AI agents? In simpler terms, these are complex systems that use AI models to interact with environments, and they have access to tools to function and to process, or like to give the model the ability to interact with the environment. Because essentially, models are mostly like text generation models or something like that. So this is like models don't really have access to do pretty much anything. So we give those tools to give AI models hands, right? Let's go to the next slide. And we're going to talk about AI agents. There are different levels of agency in here. The first one would be the simple processor. And essentially, you can like think of it as like there is no levels of agency in here at all. And anything that the AI model will output, you can just like store it in a file or like show it to the user. So there is no agents in here. There is nothing really interesting. And next step would be like a router. A router would be something close to an if else statement that lets you like figure out if the based on the EI output, should I use this or should I use that? So that's the if else statement based model agents, which are called also routers. There is also the tool calling agents, and we will talk about this actually. And also there is the multi-step agent. There is a really small difference between both of them. So the tool calling agent essentially takes tools and then just like calls them, but the multi-step agent most of the time just like uh take just like calls different functions or like functions in a for loop based implementation or a uh, while statement implementation. And finally, there is the multi-agent uh, workflow, and this is like a really big implementation. And if we're going to talk a little bit deeper, first of all, let us talk about what makes an AI model an agent. So not all AI models can be used as agents. This is very essential. And the reason why I mention this is because some of these models, if you pass some tools to them, they don't really use those tools. They would straight out spit errors or like hallucinate stuff, and they're not actually like calling these tools in the background. And the way you can figure this out is if I open this nice example in here, let me close that. So this is a random model that I chose from Hugging Face. And if you go to those models, there should be a button around here. It's called a chat template. If you open this chat template, you will find the template for the model, and you can click format or unformat based on what you want to do. Mostly I just like really love to format this to get really nice visualization. And if you check this, you will see that there is something present in this template, which is the
I
tool.
don't think we are seeing your screen. We are just seeing the slides.
No, you are wrong. I'm seeing lots of people in the chat that are seeing the slides. So feel free to like restart your call or something so you can figure out if
So
there
you're
is
showing
something.
something in the slides now, right?
The screen is part of the slide, just for understanding for everyone. It's a screenshot
okay,
of the
okay.
screen.
Okay.
Thank you, thank you.
Okay, I don't know. I'm not seeing. Okay, well, let's proceed. Sorry. So essentially, if you choose a model from Hugging Face, most of the time you will see that there is a button in here. It's called the chat template. If you click on this button, you will see that this is the chat template for that model. And some models support tools, others don't. This is an example of a model that supports tools. And the way you can figure this out, if I like search tool, you will see that there is tools. There is like, it supports tools from what I'm seeing right now. So there is a token that is reserved for the tools that is present in the chat template. Oftentimes you don't see this here. I don't know. Let me choose another model randomly. Okay, let's see if this one supports tools or not. This model doesn't support tools, so it's not an agentic model, and it's not a tool calling model. Okay, let me fix that. And if I see here, there is no tools present in the chat template, so this is not a tool calling agent. All right, that's mostly
Len,
it.
I'm sorry to cut you, but it looks like people are not seeing how you are choosing the model.
How I
So
am choosing
they
the
see
model?
the slide, but we cannot see how when you were choosing the model and you said if we go for another
So
model.
I'm just sharing just the slide
Yeah,
thing and not the.
it would be nice if we could have that, please. Thank you.
Oh, you could just proceed. Just proceed. When you want to demo, we'll see what you do.
Hello, guys.
I think
I
it's
now have
frozen.
frozen screen.
I think Lane's screen got frozen.
Yeah, let's just give him a minute, please. Thank you. Paul King, I see your hand is raised. Paul, are you still there? Paul, we can't hear you if you are saying something. If you want to put what you want to say in the chat.
Hey, who is the admin here?
So we are on the chat and seeing what's going on the chat. So me and Philip would pick it up.
Okay.
Do you have any question, Peter?
Not for now, not for the moment. Later,
Oh,
maybe.
okay. Because there will be a question and answer session very soon.
Okay.
Yeah. Let's just give him a minute. I think he's having some issues with connection. Just a minute, guys.
Oh, do anyone have, is there any limit to what teams can take regarding last urgent? Any idea? He's saying he's trying to join back, but he's having issues joining back. Oh. Okay, he's back.
Right, sorry about that. I'm back. I have no clue what just happened. So let me pick it back from here. I have no idea what is going on. I'm sorry about this. I barely used Microsoft Teams before, so please bear with it. Okay, so this is the entire screen. I don't know if you see it right now.
Yeah, we do.
Okay,
It's
perfect.
okay.
My bad. So the thing is about these models, if you go to the chat template and you click here, if you see this one doesn't have tool in the chat template, so this is not a tool calling model. All right. There is the previous model. I don't know. Let me click back and open this. I don't know if you see it or not. Are you seeing the entire screen? Could you confirm the messages?
Yes, perfect.
Yes, we can see the screen.
Yes. Okay, good. So good. All right. So this is the ZEI org, the GLM model. So if I check out the chat template, you will find that there is a tool present in here. So this makes the EI model a tool calling model because it has the capability to call tools that based on they have tokens reserved for calling tools. So yeah, that's literally it for the what makes an agent an agent. Now we're back to the presentation. Could you confirm that you are seeing the presentation right now?
Yes.
All right.
Yes, I do.
So perfect. Let us proceed. So for the agents, there are mainly two types of agents. And these are called, one of them is called the uh, mass. You have a question, right? So the tool calling agent and the code agent, right? These are two main types of agents. And the difference between them is that the tool calling agent functions on a JSON schema, but the code agent can run a code, right? To call these functions or whatever. So if I show you this example in here, this is the, let me switch to the laser. If I show you this example in here, This is a tool calling agent. This is how it calls tools. It just creates JSON, and that JSON is later on used to call these tools. And this is the code agent. As you can see, it writes code to like call upon these tools. All right, now if I move, yeah, tool calls are synonym to function calling tools. So it's literally the same. Some people call it tool calling, other people call it function calling. So it's the same thing. If I proceed to more complex example, if I'm going to ask an AI agent to give me the weather in the US, London, Paris, Germany, Tunisia, all these peoples in a single prompt. Now in here, usually if I'm going to go with the tool calling, which is limited, by the way, the tool calling is gonna be really bad use case in here. The reason behind it is because the model will have to generate the first JSON, the second JSON, the third JSON, and you have to call each of these tools. Like after each iteration, the model needs to generate a new valid JSON. And the issue in here is that not all models generate valid JSON. So sometimes there can be errors, other times the model initially the main issue in here is that sometimes the model forgets like to generate a good JSON and just like forgets a dot or a comma or something, and it's a broken JSON. So that's the first issue with tool calling. The second issue is that in here, as you can see, these are like multiple tool calling examples, and this is like not really efficient. So in here, I highly recommend that you use code agents as much as possible. This is like generally speaking, and there has been some research papers that talked about this, and they mentioned that code agents perform way better than tool calling agents. And if you can see in here the code agent example, it created for loop to call the same function over and over and over again. And so this is really good example. And another good example is that it also functions with, what is it again? It functions with complex variable types as well. So you're not bound by, hey, this is integer, this is float. So yeah, it's really good. If I go to the next slide in here, and this is an example of how you can define a tool. This works, okay, but there is a better way to create a tool. And this is not very readable, and this one is way better. All right. If I'm going to define the building blocks, yeah, I know. If I'm going to define the building blocks for a tool, initially you just have to build a function, very normal function. What you need to add upon that function is very key ingredients. And one of them is the tool decorator and the typing for each parameter, and even the output of the typing of the output function. And there is one last thing that needs to be added, which is the tool description. And also something else in the tool description, if you may notice, there is the args, which is like the arguments. You need to give the documentation for your arguments. Sorry. And you need to give your documentation about the return type if you want to. But if I go back to the previous implementation, you will see this in a more complex manner. This is the generic implementation, and if you see the generic implementation, just define each parameter and each description and all of that in a singular manner in a data class attribute. But in here, you just have to define it in your function description. It's okay, Akil. I will give you like a Q&A. There is a Q&A section towards the end, so it's okay. Anyhow, now that we have defined our building blocks for this pipeline, I'm gonna dive a little bit deeper into a more coding implementations right now, and we can start coding a little bit. Let me close all of those, and I don't know how. I don't really love Microsoft Teams. Okay, so all right, so there is two notebooks in the slide number 10. The first notebook is about running your agent locally, and this could get really bad because you would need a good amount of GPU and the whole thing. It's really consuming when you're running these agents because you would have like a really long chat history along with the agents. Most of them are really like big. I didn't find anything really small and performant. I think the smallest one that I found right now was this one, which is 3 billion parameter. I'm not gonna run this because it could take ages. Oh, this gets really complex. Initially, if I'm going to define the building blocks for this case, you will find that we have first the import, and then we define the model, and in here, this will download the model, and we will run that locally. And finally, this is the code agent, and you will pass your parameters in here. So in here, we will pass just a single parameter, which is the web search tool, and your model along with just one single parameter for the streaming, and you run that. Let's not run this. There is a better one, which is going to use an API. And yeah, let me check the messages first before we run this. So people are so guy given us this. Yeah, okay, cool. All right. So right, this is let me share the presentation once again in the chat in case anyone did skip this. We are now doing slide 10, by the way, and we're going to use the API implementation. So in here, first things first, I'm gonna run this notebook. First, I'm going to pip install, and then I'm going to do my imports. And in here, we're going to pass our notebook login. And in here, like this is the Hugging Face token. And if you don't have a Hugging Face token, you can just go to the Hugging Face settings, tokens. Right. Yeah, Hugging Face offers some free quota initially, and later on, if you reach the limit, it just tells you, hey, you reached the limit. And this quota resets, I don't know, probably I think it's around 1 day or 1 week. They reset that free number of API requests. I don't know if it's shown in here. No, it's not. But yeah, you can create a new token in here. If you're going to use just the inference, only the read access is good enough. I'm going to define one real quick in here. So let me delete this one. I always create this one for making presentations. Please do not use mine. So click here, click read, go to token name, define some random name, doesn't really matter. Any name works. Create token, copy that token, and click done. And that's it. Now, if you go back in here, if you go to the, please don't screenshot the token. If you go back in here into Colab and go to the left, there is a button called secrets, and you will notice that I have lots of secrets. And I can post my secret in here and I can go back to that token later on if I need to. If not, I can just paste it here and click login. And that should do it. All right. Keep your token. We're going to go back to this one in the other notebooks as well because we're going to use it a lot today. Anyway, now we have the token set up in the settings in the notebook. We can go on and use this. And the way we can use it is first, we are going to select a model, right? I'm going to put this in a separate cell. And the reason why I did this, the reason why I put this in a separate cell is because I wanted to show you that you can select your own custom model in here and you can pass your own model. So if you don't select anything, this will use, I think, the Qwen 2.5 coder 32 billion parameter one. This is what happens if you don't select anyone. Don't worry about it. I know it's 32 billion parameter, but this is free and you are using Hugging Face free access. So make the best use of this. And no, you don't need the fine-grained one for this task. You only need just the read one. But the fine-grained, if you have lots of companies and lots of stuff, you need a fine-grained token that is like reserved for your own personal use. I'm not gonna go into too much details, just go with the read token right now, and we can reserve the questions for this one later on. So if you don't select anything, it will go to the Qwen 32 instruct model. And you can choose any other variant in here. Just make sure that there is an inference provider somewhere. I'm going to select all of them because I have quite a little bit of money in my account. So yeah. And this is one of the models that I can use. Does it support agentic stuff? Yes, it does. It does support agentic stuff. So we can go back in here. I can do this and I can select that model. This is how you can select your own one from the Hugging Face. If you want to run the local implementation, you can run the local implementation. I just showed you both implementations, the local one in the previous notebook that I did not want to run, and this one, you can customize your own model, choose whatever works best for you. And if I run this, no, thank you. I don't want to. I regret my decision, so let me go back. There is in the other notebook, we're going to use DeepSeek, so don't worry about this. We will get back to this. Probably something related to the model or to the provider, most probably to the provider. All right, so first, define your model. Second, pass that model to the code agent. And your tools, you can pass those to the code agent. The web search tool is by default, it is part of the library if you do small agents toolkit in the pip installation. If you do pip install small agents toolkit, this will come over as a prerequisite with that library. So if I'm running this library and I say, if I'm running this script and I say, how many seconds would it take for a leopard at full speed to run through Pont d'Isard? And essentially what I want to do right now is I want the AI to first check out how long is this Pont d'Isard? Is it like a really long place, small place? I don't know. And the speed of the leopard, and then calculate that and let us know what is the total time that it would take. And if I go in here, this is multiple iterations. Feel free to read this at your own pace. And it will call multiple tools first. The first tool call, the second one, the third one. I don't know how many tools they call. And towards the end, it says something. And I'm not reading all of this. I apologize. But it says max steps reached. I think it's because we need more steps. But let's just say what's the value in US dollars? What's the okay, let me switch this. What's 1 euro in US dollars? If I'm going to run this, we can see if this works or not. I think this failed somehow. I have no clue. It was running earlier. I have no clue what is going on. Probably I did finish my tokens. Let's hope that is not the case in here. So let's just wait a little bit until I rerun this notebook. I'm not going to log in again because I'm doing something special and I have the Hugging Face token in the secrets. And if you call it like this, it will automatically be retrieved and called upon. I think I did reach the limits, sadly. Oh, this is gonna be a really awkward situation, but towards the next notebook, I'll try to figure out how I can fix this. All right, let's leave this and I'll go back to the presentation. All right, let me go to the next slide, which is slide 11. Slide 11 in here, this is going to be an agentic RAG example. And first of all, I need to define what is RAG and how does all of this like fit together. RAG is essentially like you have your own data set that is locally present, or sometimes like it's not even locally. And you have like some kind of search engine running locally. And if you say, hey, I don't know which number is at which floor Hafez's office is located, it would go back to the data set and it will retrieve something really similar to Hafez and really similar to office floor. So it will give you that. So it will bring back from the dataset the information, but this is just like search engine and it's not really smart. So something really new came out and it's called RAG. And RAG basically it's a combination between two things, the search engine and an AI model. So you go to your dataset, retrieve the results, you pass them to the AI, and you pass your prompt to the AI, and the AI will generate something meaningful for you. And this is how RAG functions. And in most cases, you wouldn't really need RAG unless you have a huge data set or a big margin of information, or if your model doesn't function really well in a needle in a haystack benchmark. I'm not, I did provide more than enough information, but we can go back to this a little bit later on. It's okay if you don't get all of this, but we will run this and we will see if our model, if our pipeline functions really well. In this example, we will use a library that I am maintaining, which is called Chunky. I know this is counterintuitive a little bit, but bear with it. I don't know why. At the beginning, I was using OpenAI, but later on I switched. But I think I'm going to go back and use my own OpenAI token in here. But anyways, let us run this notebook and I will explain what is going on in here. First, I will start by downloading some files. I'm going to download the repo and I don't really need the repo. I only need the documentation from the repo. This is why I'm running this cell. And then if I run this cell, this is going to install the library and it will install the Quadrant dependencies. And Quadrant is a vector database, Chunky is a chunking library. So we're going to combine both of them together in here, along with the small agents as well. So there is no escape on that. So if I'm going to run this cell, this will import our dependencies, and I have quite a little bit of dependencies. I don't actually need OpenAI in here because I switched to Hugging Face, but you can go back and switch all of this to using OpenAI later on, okay? I apologize for this. And this will, in this cell, you will pass your token, and this is three cells, and each of these cells like does different thing. Okay, I expanded that. Sorry about that, but this is just like in these three cells, I'm going to take those documents that I downloaded. I'm going to create a vector I'm going to chunk the documents, and I'm going to take a vector representation of each of these chunks, and I'm going to store all of these chunks along with their vector representations in this vector database. And that's what I'm going to do. And long story short, I'm going to prepare a database. This is the short version. If I'm going to expand this, first read the files. Second, I'm going to initialize my chunker and the handshake. And this is like going to combine the chunky with the Quadrant. And the next step will be, I'm going to take each of these files, take the file, parse the file, and then chunk the file, and then embed and store the file. So the cell does all of this for you. I know this is quite a little bit of steps, but Chunky abstracts all of that for you and makes it really easy for you to use. What's the difference between traditional RAG and Chunky? Chunky is not Chunky is one tool that you can use when you are building RAG. There are multiple other tools such as LangChain, Llama Index, and I think that's mostly it. And Chunky. We are like really small right now, but we are growing really, really fast. Between these 3 months, we just increased our library stars by 1,500 stars, I guess. So we're growing really, really fast. As I mentioned, you can use Chunky and you can even like not use it as well. The reason why we built Chunky is because LangChain is not really good at chunking documents. Llama Index has some really interesting implementations, but it also like has lots of dependencies, and this gets a little bit confusing for users. But with Chunky, it is dedicated for RAG and for chunking documents. So it's just dedicated for this use case, and we're not going to steer from that. All right. Let me move on to the next step. So I did take a little bit of time in this one. So next I'm going to define my tool. This is a customly created tool. As I did mention earlier, a tool is essentially a function with quite a little bit extra stuff in here. And if I take a look, I'm going to give this function two parameters, one for the query and one for the limit. And basically the query is what the EI is going to search for, and the limit is the number of the retrieved results. So I have like, I don't know, probably 200, 2000 stuff stored in my vector database in here. And I don't want to retrieve all of that and to feed these documents to the model. I want to retrieve only specific ones. So this is the limit parameter, and the return type is string. So first things first, this is just like something extra, to be honest. We can like even delete this line. And we use the handshake to retrieve stuff. And once we retrieve those results, we just combine the string and we give that string, that combined string, to the user. So this is just a function. You can even use the function as a standalone in here. And if I do this, I'm going to say, hey, I don't know, quadrant. I'm going to say limit equals 3. As you can see, it retrieved 3 elements in here. All right. And it combined all of that in a single string. Yeah, let me delete this and we can go back to the main code. So first things first, I'm going to instantiate the model. And for the model, you can use locally defined model, a Hugging Face inference client, or whatever that suits your preference. In here, I did choose the Hugging Face inference client, and I wish this works right now. If it doesn't, I'm going to switch to something else. I don't know, probably if I have something else. And in here, as you can see, we have 2 tools defined, I think. The search tool and the final answer tool, right? And the search tool is the one that I created in here. The final answer tool is just like to ask the model to like think towards the end and outputs really good output. It's not really good. It's just like a prompt, I think. I don't know what is going on in this one, but you can use it or even like ignore this one. Remove it from your tools. And as you can see, we're always still with the same structure: code agent, tools, model. And then these are extra parameters. And after that, you can say, hey, response equals agent.run, and you pass your prompt in here. If I ask the agent, and by the way, as I mentioned, this is an agentic RAG pipeline. I'm going to ask the agent to tell me how I can chunk documents and store them in a Quadrant database. So if I do that, this is the model, and this is what is going to output. It's going to run multiple iterations and run multiple tool calls. Hey, this one, that one. We can run the search tool in here. We can run whatever, I don't know, in here. What is gonna run? I think it updated the prompt in here. It switched the prompt, retrieved the new results. So towards the end, we can get the final output, but it's not really good, and we can't really visualize that. So this is a better visualization. The final answer tool, it was imported, if I'm not wrong. Yeah, this one. Final answer tool is part of the small agents library. Okay. Let me go back. So if I run the previous cell, this is the output, and the output is really weird, and we can't really make anything of this unless you just copy it and you paste it in a markdown file. But there is a better way to do this. If you are familiar with rich console, you can just like do console.print, and you convert the output into a markdown output, and this is the final output. Here's how to chunk and refine and write to Quadrant. And this is the model output, and these are some key steps that the EI said. You should do this and that and that and that. And this is what the model said. Did someone have any questions? Anyone? Okay, we are still okay. Good, perfect. That's literally it for RAG. These are just like some open source tools. You can use Shonky if you're interested. We make everything really abstracted and really easy to use. If not, there are other alternatives out there, such as Llama Index and LangChain as well. Right? We can move on to the next step right now. And the next step is the final step, and by far the most complex step in here, which is to manage multi-agent workflow. And if you want to spice everything a little bit extra in here, you can add a little bit more telemetry. And yeah, we can right now dive deeper into this, but before I dive into this, let me open Excalibur for a second. I'm sorry, I always have 3D math and tensors in here. And yeah, to explain what is a multi-agent workflow. In here, do you see the screen right now? I'm sharing the Excalibur tab. It's a white screen, right? Okay, you see it.
Yes.
Good. Okay, so multi-agent, you will always have a manager agent, and you will find your own sub-agents. Agent 1, Agent 2, Agent 3, and each of these agents has their own tools. And they are not, the manager says, hey, I want you to do this to this agent, or I want this agent to do that. And the reason why we do multi-agent is because we want we can define an agent that specializes for a specific task, or this agent is specialized for another task. And also this runs asynchronously with the manager agent. So you don't really need to wait for that sequential tool call to be run in here. So this is why we use multi-agent in here. And you can have an agent that specializes in math and has access to a database of math equations, or define another agent for, I don't know, philosophy. I hate philosophy, but yeah. And has access to, I don't know, web search, tool call, or let me switch this a little bit. Agent 2 has access to book stuff, like go to hotels and reserve hotels for you and something like that. So agent 1 is good at math and has access to a database of math stuff. And the agent 2 has access to go to the internet and reserve a table in a restaurant, or reserve a room in a hotel or something like that. So this is how we can view the multi-agent system, right? I'm not going to, in this example that we're going to run, we're going to have a manager agent and a single sub-agent under that. And we're also going to spice things a little bit by adding some telemetry. If you don't know what telemetry is a way for you to track how many tokens the manager model used, how many tokens the sub-agent used. So basically the way for you to track what is going on under the hood in here. So, sorry. The final response in here, as you can see, there is the input tokens is this, the output tokens is that, the total tokens is that. And in here for the manager, it says, hey, this and that and that, right? And again, we can run this to start up, and we just need to install the small agents library. And we're going to bring two things in here: the telemetry to track what is going on, and the number of tokens and all of that stuff, and the toolkit. And the toolkit are basically a couple of tools that were already defined in the small agents library. some examples of some interesting toolkits. You can the web search tool is part of the toolkits, and it's a really nice tool, by the way, and I use this a lot. So yeah, we don't have access to this notebook. First AI agent. Why is this in the... Okay, I'm using the previous email. A viewer. You have access, I think. I don't really know. It should be working. Ah, okay, okay. If I go to the thing, I'm connected in the copy. Yeah, you have access. You have access. It's open for everyone. All right. So let me go back to the multi-agent system. So first of all, I'm going to start up by bringing my code agent, which is going to be my main client in here and is going to do to run the scripts in the background and do all of those complex operations. And for the EI aspect or the backbone, I'm going to use the inference client model from Hugging Face. And we can bring all of these stuff as well, such as like the tool calling agent. And our sub agent is going to be a tool calling agent. So the main manager is the code agent, and the one under that is the tool calling one. All right, I will check this a little bit later. Let me finish with the presentation about the multi-agent, and we can go back to this one. All right, please remind me in just a couple of minutes. So first things first, the code agent and the tool calling agent. I'm going to bring both of them. One of the manager is going to be a code agent, and the one under that is a tool calling agent, if I do remember correctly. And also, I'm going to bring the visit web page tool and the web search tool. And again, I'm going to start in here, pass my token. I'm not going to pass my token explicitly because I already have my token already defined. You should pass your token in here manually. And in here, if you notice, I'm going to first define the search agent, and I'm also going to define the manager agent. And for the manager agent, I'm going to pass an extra parameter, and this parameter is called the managed agents. And in this managed agents, I'm going to pass the previous agent that I already created. All right, and that's literally it for how you can create those two. If I'm going to visualize what is going on in here, I'm going to tell you that we have a code agent in a higher hierarchy, and this one is using the Qwen 2.5 coder, the 32 billion parameter one. And the code agent has some managed agents under it. And in here we have a single managed agent, and it's called the search agent. And this one has access to just one single tool, three tools, sorry. These three tools are called the web search tool, the visit web page tool, and the final answer tool. And for the previous one, the code agent, we have single tool, which is the final answer tool. All right. And that's how you can visualize what is going on in here. And if you have lots of agents and lots of managed agents, you can like visualize all of that by running this final command, which is managed agent, just dot visualize, and it will print out this really nice visualization for you. And yeah, I'm not sure if this will work, but let me try to run this. I hope it works, and I hope it doesn't really take that much time. What's the difference between manager agent and search agent if they are both using the same model parameters? The difference between them is this one, the manager agent, is a code agent. The managed agent, the one under that, in here, I did choose to go with a tool calling one, but you can choose to go with a code agent. This is the first difference. So if I'm going to define them, this one is a code one, code agent, and this one is a tool calling agent, right? So this is the first difference. The second difference is the number of tools that each one has access to. If I'm going to view it's a bunch of errors, so I think I did run out of tokens. Fortunately, it's okay. We already saw the final results were pretty good. And if I'm going to talk about the tools, the manager agent, the one in the highest hierarchy, has access to only one single tool. And in here we have this tool, it's called the final answer tool. And in the managed agents, you have access to 3 tools in here. And if I'm going to visualize this, as you can see, this one has access to only this one, but this one has access to 3. So if I'm going to ask the manager and I tell him, hey, what's 2 plus 2, for example, or like, I don't know, what's the best restaurant in Paris right now? And the manager is going to ask the managed or the sub agent to go and run this, to work on this problem. And this sub agent, it will go and run the search tool, the visit web page, check the results, combine everything together, and bring the final output back to the manager agent. And the manager agent will take that from there to work on the final result, or like to recompile everything together. Always needs, so manager agent always needs to be code agent? No. What is that agent framework SDK called? For example, the syntax doesn't resemble semantic kernel SDK. No clue. I have no idea. Could you please provide a little bit extra context? Hemat, okay. Ollama is open source and free, so it has tokens. Ollama, let me explain what is Ollama. Ollama is basically you take a model and you run it locally in a quantized format, meaning you run models faster and locally. The first notebook in the slides, if I go back, the first notebook, this is an example of how you can run an AI model locally, but this one is really, really, really slow. So I just ditched the process. Feel free to run this either locally or in Colab, whichever suits you best. But also there is other alternative. This is not just the limit, because if I go into, are you seeing the GitHub? You should be seeing the GitHub. Okay, I'm sharing a GitHub screen right now. And what was I going to say? Yeah, The small agents, it functions with lots of providers. If you're going to use the inference client model from the from the Hugging Face, this is how you can use it. You can just pass in your provider. I think I should use my providers because I have quite a little bit of credits. So probably that should fix that. If I use the provider, because I don't know. I will check this later, right? So you either use the providers from Hugging Face or Light LLM if you want to run a model from Light LLM using your own Anthropic tokens or whatever. And you can also use OpenAI if you want to. So the small agents library has an SDK that functions really well with the OpenAI models. And it also like this SDK also functions with the Hugging Face inference providers. So this example is really bad, but it does work with OpenAI as well. I'm gonna skip this one. This is OpenRouter. The transformers, if you're running something locally. Azure, if you have your own credits, or Amazon Bedrock as well. So you can just like pass in your parameters. That's how you can define your model. And that model you can pass along later to the agent. As you can see, we first define the model and then pass that model to the tool calling agent or the code agent. And this is literally the same syntax being repeated over and over and over and over when you are using the small agents library. I'm going to take a couple more questions. May I ask how to decide if I should make the agent code agent or a tool calling agent? I think you should always try to go for a code agent, but with reservations, all right? The tool calling agent, as I mentioned, it really depends on the model's ability to generate valid JSON output. So if it generates a JSON output or like a dictionary that is broken, that's going to be an error and you just need to like reiterate over and over again. So if you have a bad initial model, this is going to be like breaking the whole thing. But with the code agents, it just works, I guess. I think there has been lots of research papers about this, and I don't know, lots of research papers about this, and I remember that they did the benchmark about all of these models, and they figured out that code agents perform way better than tool calling agents, and they are less prone to failures. But on another note, you should also note that there is an issue in here. And code agents, for example, if you have a malicious prompt or something broken or the models, I don't know, it can run error like malicious code on your machine. So be vigilant. And small agents for now patch this by removing the OS library. You cannot really import the OS library using small agents. And even the imports area is like limited. You just have to say, hey, you have access to this and this and that library, and you can't really go beyond those. Else, if it's trying to import a library and it's not in the list, it's going to break things. It's going to say, hey, this is malicious, please don't. So a really bad example of something being run is os.remove system32. Pretty sure you have seen this before. Imagine if your agent runs this command in your computer, right? So code agents can run commands, and if they can run commands, they can run malicious commands. So yeah, But there is another patch in here for the code agents. You can use E2B sandbox, and even OpenAI is using this. E2B is basically, think of it as a virtual machine, but it's sandbox. Sandbox functions really fast, and you can really quickly like delete everything and run again. So it can be used with Perplexity, Hugging Face, PGA, Manus, Grok, Lendly, OpenAI, Meta, Anthropic, literally everything. The sky is the limit. So here's an example of how you can use these sandboxes. Just bring your code interpreter and you say, hey, sandbox.run. I don't know if you can run this locally or not, but I'm pretty sure there is, if I'm not wrong. Feel free to check this. This is very good if you are going to run agents locally. You should try to use E2B to run everything in a secure manner. Else, if you have your API token from E2B, you can use that as well to instantiate your E2B coding environment. And yeah, what else? From my knowledge, Olama, as I mentioned, it's literally similar to how you are downloading a model and running that locally. It's not, I don't even have Olama in my laptop right now, so I can't really run this. And but also like if I'm going to download another model right now, that's going to take quite a little bit of time. And I don't want to waste everyone's time for you trying to wait for me until I finish running this. But feel free to use these reference notebooks that I provided to build upon it for your future work. So that's your task after today's call. You will go home, open your laptop, try to build your own agentic workflow, and yeah, build something with that. The sky is the limit. Also, like, try not to use Hugging Face inference providers because it's limited, as you can see. Like earlier, I was functioning and using this one, and there was no issues with that. But I guess I finished my tokens right before the call, so I'm pretty sorry about that. Yeah. Silly question, but how big is the small agents if I import locally? Uh, if you import the small agents locally, it's not really that big. I did run it locally earlier, and there was no issues with that. It ran without any issues, actually. Like, I don't know. Is this that? Yeah, I think like it's very, very small. Like actually, by far between all the agentic SDKs out there, small agents is literally the smallest one out of them in terms of the total number of lines of code. So yeah, there is like quite a little bit of agentic libraries out there. There is LangChain. There is also Llama Index has some really nice, interesting combinations and integrations with agentic workflows. There is also Crew EI. I did not mention this, but yeah, Crew EI. But I don't really recommend using Crew EI much because if you do pip install, it just installs lots of libraries and lots of dependencies along with Crew EI. I think, yeah, but I did see lots of people use it before. I've used it only once or twice before, so I didn't really have a really good experience with this one. There is other SDKs out there, I'm pretty sure, but yeah. And I'm going to take one last question and then we can bring it back to the event hosts. Thanks a lot, Martina. Have a good one. Where is it? Clarify also provides hosting for models if someone into that. Nice. All right. Feel free to even like reach out even after the session, and I will point you if you want to add Clarify as inference providers for Hugging Face. I'll try to help you with integrating that into their JavaScript infra if needs to be. The question is small agents smaller than chunky. I need to check this one. But I think chunky is chunky a little bit, but I think probably chunky is a little bit smaller. I don't know. We have to see. Yeah, one last question. Well, what is the last question? We have recording of the session. I think Philip will reply to this. I think let me go back to the presentation and switch to the last slide. And I want to say thanks a lot, everyone, for your attention. I think I stopped the share screen. Thanks a lot, everyone, for your attention, and I will bring it back to Philip. Philip, if you want to give any last words.
Yeah, thank you very much. Thank you very much for that awesome presentation. You've actually told us what agents are, told us about the tooling, calling agents, and code agents. When we are able to pass parameters to extract JSON schema, then we are looking at the tooling agents. And you've also told us about the agentic RAG and the multi-agent systems. This session will be on our YouTube channel. Let me share the screen so that we could see our channel for those that we're still going to post it on the chat right now. Let me just quickly share this. Oh, sorry. Okay. Yeah. Okay. Yeah. So this will be available on our channel, which is this is our channel here. PyData Milton Keynes. Can we find it on the chat already? Let me repost it. Okay, let me just repost it again. So you could subscribe so that you get notification once it drops. I think that would be the best thing to do. Just subscribe, and just because you can subscribe on other social media outlets. Subscribe to our LinkedIn. Our LinkedIn is here. Our PyData Milton Keynes, YouTube, Twitter, and we'll also still send it to you to your inbox. As long as you are REST-VP, you'll get notification once it's available. Once we upload it on YouTube, we're going to send it to your mail. And yeah, so subscribe, share the message. I think this should be, let's get your feedback. Let's get your feedback for how would you describe the session. Let's do that. Let me see if I can. Yes. How would you describe the session in one word? Yeah, can we get your feedback, please? Just scan and let's see your feedback, please.
Yeah, it was really nice. Thank you very much. It got better and better at the end.
Good. Thank you. Thank you for joining. Thank you. But also want to have a feedback there. So, I mean, what next? What next? We'll keep getting better. We keep pushing this. Keep bringing you trending contents in the data space, in the AI space, the open source space. You keep getting that, and we are looking to host our in-person events. Right, we are hoping to host another event probably before the end of the year, and we'll be partnering with some companies, some AI companies, to make that an awesome event. So just keep your ears on the ground, and but that will be an in-person event. That's what we are looking at. So if you really want to attend, then think of December, what you can do in Milton Keynes in December, and then plan towards that. Thank you once again. Thank you for our awesome speaker. Thank you for everyone. Thank you everyone for joining. It's great still here. Great
Yes,
still.
I
All right.
am here. Thank you so much, guys, for joining. We are absolutely grateful. Thank you for giving us your time. I see people are excited for our next event. I would say, Lane, it's good. It was amazing to have you. It was such an informative session. I would say keep your eyes on our social media platforms. Keep your eyes on our social media platforms, especially our meetup page for any announcement, so that you are the first to know when we announce our next event. I see someone is asking if we can do an hybrid event in December. We will see how feasible that is. And then we'll be working towards having that as well. But definitely, irrespective of if we have an hybrid event or not, we will definitely be putting that on our YouTube channel. Please subscribe on the YouTube channel, so that as soon and turn on the notification, so that as soon as it comes up, you will be the first to know. But it will definitely going on our YouTube channel. We're so excited to have you. Thank you for joining. And with that, I think we
Someone is raising his
just
hand up.
gave us, we got 30 minutes back. Like, we'll have 30 minutes back. I would say it's a good time for us to go back. If you took notes, time for you to go back, refresh your notes, look at those Google Colab notebooks again, and let that guide you. Till our next event, thank you for joining PyData Milton Keynes. Bye.
Yeah, we have a hand up. Is he still raising his hand up? Yeah, someone's hand is up. Me. Please can go ahead and speak. Someone is raising his hand up. You can go ahead and speak. If you want to ask any question, you can go ahead and unmute yourself. Just talk. If you want to give us feedback straight up, you can also do that right now. All right. Thank you once again. Thank you, everyone. I think that should be all
Thanks a
for.
lot, Grace. Thanks a lot, Philip, for the invitation. Thanks a lot for hosting this event. It has been really great to meet up everyone. And yeah, I hope this has been informative, and thank you.
Yeah, great. Please, if you feel free to DM me if you want to, if you want to give any of these sessions, right? And you're an expert in your field, you want to drop something, just DM me, right? So just slide into my LinkedIn or just message me on the platform, and we are happy to have you as one of our speakers, right? So thank you very much. Thank you for joining. Thank you.
Thank you.
Great.
All right. Stop recording.